let's take a look at the first 8-1 assignment. Let's look at some of these.
Whoa.
Okay. It's been a little while. Let's review a little bit. Now, if we're trying to simplify ratios with units, we've got to make sure we're dealing with the same kinds of units. Otherwise, it doesn't make any sense to make these kinds of comparisons. For example, 4 days, the ratio of 4 days over 16 hours, or 4 days to 16 hours. Now, 4 is a smaller number, but obviously 4 days is a longer time period than 16 hours, right? So in order for us to make this a valid comparison, we got to turn both of these quantities into the same units. Now, what we talked about doing in class, and I don't care, honestly, if you do this. I've done my piece. I've talked about changers. I think they're a good idea. You're definitely going to end up using them in science. But for simple cases like this, where there's just a single change, if you really don't want to do that, that's fine. Let me just quickly remind you how it looks if we do use a changer, and then I'll show you kind of the shortcut that you might choose if you wish, and I'm fine. Okay, so if we want to, convert that, well, which one are we going to convert? Days to hours or hours to days? Days to hours. We always start with the bigger unit and convert it into smaller units, right? So we could multiply through by the changer. Now we're going to want to have days on the bottom. So those guys will cancel, right? And then hours on the top. And 1 day is how many hours? 24. So there we go. Now we could just multiply straight across. Well, the shortcut is, as you've probably seen, if I do 4 days over 16 hours, I could literally just say that a day is 24 hours. And so I could multiply the 4 times 24 hours, right? 4 days is 4 times 24 hours, because 24 hours is a day. So if I write it that way,
Are we staying in here all day?
no, we won't. This should be pretty quick. So if I multiply straight across, then 4 times 24, we could make that 96 over 16. And hours over hours cancels. And then I just get the fraction 96/16ths, which I've got to reduce. Now, if the question doesn't specify, if it doesn't say round your answer to 2 decimal places, should we assume that we can round our answer to 2 decimal places? No, we shouldn't. Because that's a changed answer. Now, here's how I want you to kind of start thinking about that. This is the way you should think about it mathematically. If the question gives you permission to provide an answer that's not accurate, that's not exact, then go ahead. But you should always assume otherwise that the math gods are asking for an exact answer. Unless they tell you you can kind of fudge it and make things a little bit less exact. You shouldn't make that assumption. And so 96 over 16, well, let's see, that one actually works out, doesn't it? 6, yeah, that's just 6, right?
What did you say we could assume we could do that?
If this were something, let's just say, here, I'll give you another example in a second.
I just wonder what that word you said was. It sounded odd.
Oh. Okay. Okay, so 96 over 16, that reduces to, 16 goes into 96 6 times. So that would reduce to 6 over 1, the units cancel. And so then in Moodle, they actually want this written in the form of, a colon ratio. So what goes where? If the answer is 6 over 1, what part goes where?
6.
Yeah, good. 6 goes first and 1 goes second. The numerator always goes first, denominator second. So I would just do, oh, it's on the other screen. So I could just do 6, 1. There we got it. Yeah, okay. So there's one of those. Now there were some other kinds that came up, and there's quite a few of those to look at. When you get down to, oh, I know what I was going to say. Yeah, like for example, like with these guys right here. I think you'll see it with these. When I give my final ratio, what if my ratio is something like 5:3? If my final ratio looks like that, man, is it hot?
Yep. Yeah, we should probably turn on the loud.
We'll get there. We'll get there. As soon as we can handle it. So if my final answer is 5/3, can I write that as a decimal? No, I can't, because that's going to be repeating decimal. So the answer I would have to put in here would be 5/3. Okay, now if the answer instead, though, were something like, pretend it wasn't that. If it were something like 5/2, as a decimal, that would be what? 2.5. That's exact. So I could put in the answer 2.5 or 5/2. Either one would be okay. There's no loss in accuracy or exactness if I write that as a decimal, because it's an exact terminating decimal, right? Does that make sense? Okay. There's some other kinds. You saw in here too. You had these kind, right? These solve the proportions kind. Solving the proportions. So what do we do with those? Whenever we get a ratio equation like that, a proportion, what do we always do to solve those? Remember? It's been a little while. Well, cross multiply. Right, cross multiply. This time we can't really cross cancel, because cross canceling, we can only cross cancel when we're multiplying stuff. If I've got an equation with fractions on both sides, then that's when I want to cross multiply. And the advantage of that, if I cross multiply, I'm going to turn this in from a fraction equation, which we don't like, into a non-fraction equation, which we do like. So if I take this one right here, for example, and I cross multiply, x times 26 is just 26x. 13 times 13 is 169. And so what do I do to solve for x? Just divide both sides by 26, yeah. So x equals 169 over 26, which, maybe we can reduce, maybe we can't. Okay? All right, I can turn around. So does that make sense? Okay, that's how we do those. Now, if we move on to the next assignment, the one that not many people have started on. So if we grab this guy. Okay, notice these are harder looking ratios. Okay, how do we deal with stuff like this? Same way. If I want to solve that first equation, all I want to do whenever I have a ratio equation, I always cross multiply to solve it. But what do I get this time if I cross multiply? Well, you could. I mean, I could flip both sides if I want to, but I don't even have to do that. I don't have to do anything different than what I've been doing. All I do is just cross multiply. If I cross multiply, though, what do I get this time? Well, if I do this cross, 21x. Okay, what about the other cross? What about the upward cross there? Okay, yeah, now I'm having to distribute that 5. I'm multiplying 5 times this whole thing, which means I have to distribute the 5. What I've really got there is 5 times the quantity, 4x plus 5, right? And then if I want to solve that, now it just becomes algebra, right? Now if I just distribute the 5, I get 21x equals 20x plus 25. And then what would I do? What do I do to solve for x? Yeah, I'm just gonna gather the x's on one side, the side where I have the most of them, and then isolate x, right? Okay, so in this case, I just get x equals 25 if I subtract 20x from this side. So. Right? Okay, there are more of those kinds of problems, and they all essentially are boiled down to problems like that. You get some in different forms, though. Let's see if I go to the next page. You're going to get some of them that are sort of geometric, like this. But same deal, isn't it? We're just going to set up a ratio. If we know that the ratio of BC, well, that's this distance, to AB is 3 to 8, I can just set up a proportion there, right? That tells me BC is x plus 5. AB is 48. So x plus 5 over 48 must equal 3 over 8, right? Now I can just cross multiply and solve for x. Get the idea? Okay? All right. That's it. This is. I'll give you a couple days to kind of finish this up. I'll give you today in the lab, and then we're going to start talking about some more new stuff. What's that? It's just given to us. The ratio is 3/8.